The Biomechanics of Shooting a Jump Shot by Diamond McFall. 3 biomechanical principles can be applied when shooting a jump shot: free body diagrams, ground reaction force, and the magnus force. Free body diagrams. In order to see the external forces acting on a person as they shoot a jump shot, you can draw a free body diagram. In this example, the system is defined as the person and the basketball. Only taking external forces into consideration, first you have the force of the weight of the person, and next you have the force of the weight of the basketball. Lastly, we have the normal force. The normal force is perpendicular to the surface, and it is the contact force that the ground exerts on the person. In this example, the system is defined as the upper arm, the forearm, and the basketball. Only taking external forces into consideration again, first we have the force of the weight of the upper arm, and next we have the force of the weight of the forearm. Then we have the force of the weight of the basketball. We will not include the forces of muscles since they are internal forces and we are only looking at external forces. The last force we can add is the force of the shoulder joint. The force of the shoulder joint can be split into both its x and y components. So in the diagram, we have the force of the shoulder joint in the x direction and the force of the shoulder joint in the y direction. The next topic we will cover is ground reaction force. Ground reaction force is the force exerted by the ground when an object comes in contact with it. When a person is shooting a jump shot, so let's take Allen for example, the ground reaction force occurs between his feet and the ground. When the person is shooting a jump shot and is motionless, this is an example of Newton's third law. For every action, there is an equal and opposite reaction. This means the ground reaction force will be equal and opposite to the weight of the person and the weight of the ball. If a person is still accelerating or changing direction while shooting a jump shot, their ground reaction force will also change. And as we learned in lecture, force equals mass times acceleration. For example, if Stephen Curry was running forward while shooting a jump shot, then his ground reaction force will not only be pointing upwards, but it will also be pointing backwards, which causes his jump shot to be vertical and not forward. The last topic is the magnus force. The magnus force can be very important when it comes to shooting a jump shot. The magnus force can explain how a projectile, such as a basketball, can change its trajectory when moving through a fluid such as air on its way to the hoop by spinning. When a person slides their fingers down while releasing the basketball for a jump shot, this causes the basketball to have a backspin. This backspin causes the basketball to move in a clockwise rotation. This clockwise rotation causes the airflow to move at different speeds around the ball. On the top of the ball, the velocity of the air is moving faster than the velocity of the air moving at the bottom of the basketball. However, due to this difference in velocity, there is also a pressure difference between the top and the bottom of the basketball. Because fluids, such as air, flow from high to low pressure, this pressure difference causes the air on the top of the ball to be pulled to the bottom of the ball. This causes an upward force on the ball, which is called the magnus force. The backspin of a basketball is important for 2 very important reasons. First, it gives the basketball this floating effect. The floating effect helps the basketball to keep a vertical trajectory while it makes its way to the hoop and through the rim. Second, the backspin of a basketball affects friction if the basketball were to come in contact with the rim or the backboard. In both cases, the backspin increases the chances that the basketball will bounce.